Welcome back to Applied Mathematics. In this video, I want to work through some unit conversions. As we've talked about previously, different units of measure can be used to measure the same object. We can measure the width of a table in inches or in feet, and even though numerically they look different, they are measuring the same thing, so they have to be the same value. And if we have the choice between measuring in feet or measuring in inches, there has to be some way to convert and verify that those measurements are equivalent. The method of notation that I'm going to use in this class is called the unit factor notation. It starts off with the basic idea. Let's continue with inches and feet. 1 foot is equal to 12 inches. Rearranging that equation, we know that if we take something and divide by itself, we get 1. And we're going to do that in a very convenient way for ourselves, but not so obvious at first glance. If 1 foot and 12 inches are the same measure, then if I take 1 foot and I divide by 12 inches, I should get 1. Or if I did that in the other direction, if I took 12 inches and divide by 1 foot, I should get 1. And so going back to our theoretical table that we have measured, if we measure that table in inches and we get that the measurement is 42 inches, well, I can divide 42 inches, or I can multiply 42 inches by 1 without changing the measurement. I'm going to choose this variety of 1 in the form of 1 foot over 12 inches. Now, multiplying a whole number times a fraction is a little bit messy. Generally speaking, we take the whole number and we divide it by 1 because dividing by 1 doesn't change anything. And now it looks like two fractions being multiplied. When we are multiplying fractions, we've learned that we can look for common factors between the numerator of one and the denominator of another. In this case, I'm going to treat the unit of inches as a factor and cancel out the inches in the numerator with the inches in the denominator. Right? That leaves me with 42 in the numerator, 12 in the denominator, and the only units I am left with are feet. From here, I can grab out my calculator. I can divide 42 divided by 12 and get 3.5 feet as the equivalent measure of 42 inches. You may have, in a previous course or previous study, seen other notations. Probably the most common notation other than the unit factor form, which is the form favored by mathematicians and physicists, is chemistry's H diagrams. Right? In chemistry, we're going to take that same measurement of 42 inches. We're going to draw a box that looks something like this, and we're going to put in our next measurement, 1 foot over 12 inches. We're going to cancel out the inches, and we're going to see that that still is 3.5 feet. So notationally, it looks different, but it is the exact same calculation. I am going to use the unit factor notation for the rest of this course and any other courses you may be taking with me. I did want to at least mention this other notation because it is fairly common. I apologize, the green screen is not being very green screen today. Anyway, I wanted to mention this notation because I very often have students coming into my classes who have taken a chemistry course relatively recently, remember seeing something like that and want to use it. If you've seen other notations in the past that work and make sense, I don't have anything against them, but I do want you to get in the habit of writing out these conversions in more detail than you might initially think. Right? Converting between feet and inches is a very simple conversion. There's not a lot that happens here, and a lot of people will internalize, oh, if I have a measurement in inches, I divide by 12, that gives me a measurement in feet. That's great. And on an exam, if you did that, I would have no issue with it whatsoever. But as a practice tool, I want you to get in the habit of writing out the conversions in detail, because we will later on in the course get to some much more cumbersome conversions, conversions that take 2 or 3 or 4 steps. And if you are already in the habit of writing out your conversions in detail, then when we get to those more cumbersome conversions, you will know exactly how to proceed, and you'll be able to extend this notation out without any issues. So as a practice tool, please take the time to write out the conversions. Again, this method, that method, another method, I don't really care, but write out the details. Write out how you are getting from place to place. Don't just say, oh, I divide by 12 and call it a day, because things will get more complicated later. All right, get myself and my horrible green screen out of the way, and let's look at one more example here. We know that 1 pound is 16 ounces. So if I have a weight that is, say, 4.25 pounds, and I want to convert that to ounces, I can multiply. In this case, I need to have the 16 ounces in the numerator and the 1 pound in the denominator, so that pounds here and pounds there will cancel each other out, and I will be left with ounces. So we will have 4.25 times 16, and the measurement will be in ounces. My calculator is happy to tell me that 4.25 times 16 is 68. All right. That's all I have for you on this one. It's not a very complicated process to go through unit conversions, but if you haven't done them or you haven't done them in a while, take some time, practice writing them out, make sure you know what you're doing, and I'll see you in the next video.